Hello again. Welcome back. This is Dr. James Camp from Lee College in Baytown, Texas, your friendly computer science professor on the web. And I'm here to talk about files. Thing we're introducing in today's lecture is not the idea of I/O itself. We've been doing that all semester with inputs and outputs to the screen. But this time we're going to put those inputs and outputs somewhere permanent in a file on a disk. Okay. Now, originally, we used to think of all input and output as happening on disks. Okay. Well, originally, really, before disks were invented, we had rolls of tape, giant rolls of magnetic tape that we would write to. But that's really ancient history in most of the computing world. Some people still use tape drives. They store magnificently large amounts of information. So if you're trying to store the whole human genome, for example, you might still use a tape drive for that. But for most things, you can use a hard drive. And the idea here is that the hard drive is blocked into concentric circles. And each of those concentric circles is divided into sectors so that when we want to write a file, say it's 4 blocks long, the file might be written here, 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 and here. Okay? So I print out the contents of my daily journal, say, my daily journal entry. It'll get written and that's all the space it needs on the disk. Now, in reality, my daily journal entry is a lot shorter than that. It might just take 1 block. But let's say I had maybe more of my semester term paper that needs that much room. Okay. Over time, though, files build up in different places on the disk. They don't always get written in consecutive places. Okay. And so when I go to write my new file in green now, I have to write here, 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 here. Okay. That's called a fragmented file. Fragmented files are a little bit bad for disk performance. It's best to have your files generally in the same place on the disk. But the disk is spinning fast enough that, to all intents and purposes, you can still load most files fairly quickly, even if they get fragmented. In modern computing, we no longer have hard disks. We now have these things called solid-state drives, which are just big blocks of memory that doesn't go away when you turn the power off. Okay, what we call non-volatile memory. But the same principle applies. You go to write your file. At first, there's plenty of room, so you just take 4 blocks right next to each other. Over time, however, some of those blocks get used as time and space permit. So now when you go and you want to write another 4-block file, it'll go 1, 2, 3, 4, and it'll also be a little bit fragmented. However, because of the way solid-state memory works, fragmenting isn't an issue with solid-state drives anymore. There used to be programs you could buy that would defragment your hard drive and get you a little bit faster performance. Those programs should not be used on a solid-state drive because the SSD doesn't work the way a hard drive does. So what's the point of all this? the point of all this is that we're in C++, we can put cout my diary. Maybe I've just written a really big long string called my diary, right? Well, we can do the same thing with a disk. We create an OF stream. That stands for output file stream. Maybe we call it fout instead of cout. And then we come over here and we say fout my diary. And my diary entry is pretty short, so it just comes and takes one little block on the hard drive here. And then I can come back later and create an IF stream called FN, maybe, or in file, or whatever I want to call it. And I say FN old diary, and it goes and it, I have to give it a file name, but it goes and it finds an old diary entry, maybe this one, and it reads it. Okay. And that's how files work in C++. You just associate a spot on your disk with an input or an output, and then you can use it just like any other I/O that we've been doing in the class this semester. Okay, you'll learn plenty more about files in our lecture today. I hope this has given you a good context for understanding what a file is and how they're used. So go on with your studying. Good luck and happy programming.